Right, good morning everybody. Thank you for joining me here today. We're talking about 5 minutes to a green light today, 5 minutes to be ready to go with some of our sensors connected to our soon-to-be released SIG 300 IO-Link Master. So I'd like to tell you a little bit about the IO-Link Master today. It's coming out on April the 24th, going to the market. So you guys are one of the few first people to actually get to know about this before anybody else. So I'd like to take you through some of the key features, why we've developed this product, and what it can do for you as machine builders, and how you can help your end users in their goals as well as part of that. My name's Charlie Walker. I'm the digital sales consultant for SIG UK. I've got a history in engineering, service engineering, site engineering, and then moving into sales, development, also with the software side of things. And this device sort of fits nicely in the middle of all those things, moving the OT into the IT and all of that standard spiel that I'm sure everyone's heard a lot about. So we have developed IO-Link Masters in the past, but we felt we could do better. So we've spoken with a number of customers, both end users and machine builders, and found out again what it is the marketplace needs. Based on continued experience that's gathered over time. IO-Link's been around for quite a while now, but people are still getting to grips with it. IO-Link sensors obviously offer the best of both worlds. We've got the ability to use them as a process data gatherer, your ons, your offs, your levels, your distances, but we can also communicate directly with the devices over IO-Link. So people are starting to get a better idea now how to make the most of those kind of features. Helping out with maintenance, exchanges of faulty parts, maximum uptime, all the sort of things that your end users are going to want to benefit from, really. Fast commissioning out of the box, so if you're putting a machine together, you don't want to be spending hours and hours trying to figure out how to get things connected. You want to get it in, you want to get it set up, you want to minimise that time taken, minimise mistakes, and then obviously maximise your profit on the amount of work you're putting in. We used to make a 4-port master. When we went to market with that a few years ago, as I say, people were starting to get into the IO-Link side of things, and as a result, they didn't feel that everything needed to be IO-Link, so 4 ports was enough. That is no longer the case. So people really want to maximise their port usage on the device that they're installing, and you'll see a little bit further on that we've not only gone with the idea of 8 ports, which the market is demanding. We've also taken the step to include both A and B type ports on the same device to minimise stock requirements in terms of different types of devices. Hopefully you'll see the benefits in that as well. So basically the SIG 300, it is an IO-Link Master. It does all the things that an IO-Link Master should. That obviously enables simple communication. It means we can communicate with PLCs across field buses. But the SIG 300, our device, is also capable of running as a standalone unit as well, because it has an onboard logic editor built in, which means that to one degree or another you can outsource PLC tasks to the device, low-level calculations and aggregations. That gives you the benefit that you, as an end user for example, when your customers, they will be able to make use of these and add them onto systems you've already provided without needing to necessarily cause any undue stresses to the existing architecture. You might not want them to do that, you might want them to come to you. So depending on how you lock it down as a machine builder, you've got the options to be flexible. Here we've got a device blown up a little bit, so we're working with the standard field buses that you're probably all familiar with, Profinet, Ethernet IP and EtherCAT. Got a built-in Ethernet switch, so you can data chain these together, same with the power. USB-C connectivity for easy setup, so even if you don't know the IP address of the device, even if you've literally just pulled it out of the box, you can still connect with a USB-C cable and you've got immediate access to configuration, the web server that's built into the device. So literally within 20-30 seconds of powering up, you're connected, you can see what's going on with the sensors that are connected to the device. We've got A-coded connections, which is the IO-Link standard. You'd expect. We've got 6 Class A, 2 Class B ports. The Class B ports, as you'll see in a second, can also be used as Class A if you haven't got a requirement for actuators. Integrated logic editor, as I said, and then we've got something we call dual talk, which is the ability to communicate with field buses via PLCs, but at the same time we can take data out of the device via one of the IoT channels MQTT, OPC UA, or REST API, and we can move that data simultaneously. So while we've got one thing going on with the process data, which is your standard operation of the machine, we've also got condition monitoring, monitoring of the sensors themselves, the more in-depth service data that's going on in parallel. So you've got the best of both worlds simultaneously. That really allows you to maximize the IO-Link device's design methodology. It's not just about process data, we've also got service data and the stuff that's going on behind the scenes, behind the curtain. We'll talk a bit more about the products. Okay, so no matter which one you buy, you get the same form factor. The only difference is that the REST API only version, which doesn't have a field bus, that does not act as a network switch. That has two totally separate, isolated network channels. The other three all have a switch that allows traffic to pass through to enable you to use it in a daisy chain manner if you chose to. And then we get on to the port class A and B situation. So best of both worlds in one device, basically. So if you've got sensors, input devices, things that are detecting the eyes and ears of the machine, then you would normally use a port class A. However, if you've got to drive something, whether that be a motor or an actuator, something that requires a little bit of oomph in terms of the current supply, you'd probably want to use port class B, because you can also supply an additional set of voltages via that port to the device that needs it. So we figure, why not put both into one device? If you don't need port class B, you can still make use of it as a port class A, which means it's an 8-port port class A device, but you don't have to then start having a separate master or a separate piece of hardware to enable port class B devices that you may want to use on your system. We think it's the best of both worlds. It'll be interesting to know your feedback on that later on, or at the stand if you get a chance to come and see us, see what your thoughts are. Always welcome feedback. So just a sort of example, you can see that we've got one master here that's not only taking input data via the Class A devices, it's also able to drive Class B devices. And obviously you've got the length of the cables up to 20 meters between the master and the device, so you could run two separate sort of miniature machines off one master if you chose to. The idea here is that we're showing Class A, Class B within one device. No need to have two separate control structures within that. Something else that we felt was very important, based on the feedback from customers and users, was the fact that an A-coded power connector wasn't enough to provide the amount of juice that you might need for your overall application. So we've gone with the L-coded connector. It's a bit beefier, get a lot more current through it. We can have up to 16 amps into this device now, which also allows us then to drive those actuators with a bit more power if you need it. So what we figure is that allows you to make the most of the situation. It also, because we've daisy chained it, means that you can minimize cable runs to these devices. So when you're building a machine, you obviously don't want to run parallel cables if you can avoid it. We think this helps you to do that. I'll stop going on about the Class A and Class B now. But basically this is the layout. So the bottom 6 ports are Class A, the top 2 ports are Class B, but as I say, the Class B can be used as Class A, provided you wire it correctly. Okay, so another very important thing that we've gone with on this device is the logic editor. So an onboard built-in logic editor, which allows us, once we've got IODD files for the sensors that are connected, or the actuators or the output devices that are connected, we can use the IODD file to populate the function blocks within the logic editor. So in this example, we can see we've got inputs from the field bus on this one being mapped across to RESTful outputs. So we could be connected to the PLC could be sending data into the master. The master would then move that data and make it available to the IoT mode. That is what this example here is doing. But equally, on our stand, if you come and have a look later, you can see we've got a distance sensor that's being mapped straight into the logic editor. That value is then being modified by our mathematical calculation and then pushed out to one of our smart light towers. So the further the distance from the sensor, the fuller the light becomes. It's a very simple application, but it's quite powerful in terms of showing how the logic editor can work. So we think that that's quite a useful feature. It allows you to have best of both worlds. You've got the ability to create basic logic and also the ability to use this device as a full field bus Profinet, Ethernet IP, Ethernet device. So the IoT interfaces that are on the device, very important to know what they are. We've got REST API, pretty much an HTTPS GET command usually, which basically means computer A speaks to the master, asks for some information, it sends it back. Simple, effective, works very well. In addition, we've got onboard MQTT. So if you're not familiar with MQTT, it's effectively a broker-controlled situation whereby you send data to the broker. Anyone that's subscribed to the broker then receives an update when that data changes. We've got that built in so we can connect directly to the broker without any need for any middleware or middleman type of connectivity. Again, very useful, very heavily used in the industry these days. OPC UA, I presume there's a few people familiar with that. A lot of companies now are making this one of their primary use cases in terms of communication between various devices in their systems and within their cloud-based systems as well, because we can extrapolate the information and move it through all of the infrastructure. So again, that's on board. And a lot of people are still saying to themselves, why use IO-Link at all? I'm not going to read all that because that would be very boring, but for the reference, the key things for the machine building world, reduce wiring effort. Okay, so if you've got to strip, cut, trim, mount, all those kind of things, every single connection that you're making, first of all, there's quite a large chance of making an error. Someone's going to double check the work. And secondly, it takes a long time. The way we're using standard molded M12 cables with a specific torque tool means that you can literally screw the connectors in, clip them in, job done. You don't have to check them because you know they're right. So the amount of time it takes to wire a system can be massively reduced. Maintenance, if as a machine builder you want to make sure that your customer has maximum uptime, it's possible to configure the system so that any sensor that breaks can be replaced by a sensor of the same type and automatically programmed via the IO-Link master, so there's almost zero downtime. You're up and running in about 1 second once you've changed the sensor over. So a sensor that is being configured to do a particular job that would normally require an interaction to put it back the same way, if you put the exact same sensor in, plug it in, click, 1 second, you're up and running again. No messing around. So minimum downtime for your end users. Efficient engineering, obviously, the ability to communicate via ring topologies or any of the other preferred connectivity solutions. And we talk about Industry 4 applications. What we're talking about is that dual talk, that IoT ability to do the process of the job over here, but also monitoring various elements from the sensors on the other hand at the same time. A lot of people talk about IO-Link masters being too expensive or the IO-Link system still being too expensive. We believe that overall, when you take everything into account, the total cost of ownership is actually better when you start to use IO-Link in the correct manner. If you do everything properly and make sure that you're maximizing the benefits, then you can actually generate a financial benefit for yourselves in terms of the overall cost. As I mentioned earlier, we've got a web server built into this device, so a lot of competitive components or competitor products require a separate piece of software, something else you have to download, install, to then be able to communicate with your device. Because ours is built in as a web server, it's always there, it's always available. You can go in via the USB port, as I said, straight out of the box, standard USB-C cable, available off the shelf, or you can communicate via the IP address of the device as well. So 2 channels there. One is very useful if you've got a fault finding situation, or if somebody's messed around, changed something that they shouldn't have done, you've always got the option of going in via the USB, which we think is extremely useful. It's very user friendly, simple to understand. It's got an IODD interpreter built in as well on this device, and a very easy to use IODD library within the software. Literally drag and drop, very simple, very straightforward, as you would expect. So we believe that this device is basically usable across all industries. There's no real area that we don't think it could be made use of. Okay, so that's the reason for this slide being in the deck. It's multi-use, very, very flexible. So we're ready with dual talk. We've spoken about that. We said IoT connectivity at the same time as your field bus process data. The main reason that this is valuable is because you've got the ability to monitor your system at the same time as it's doing its job. Okay, that's basically it in a nutshell, and we think that's very powerful. Simplified installation, as I talked about, it's literally M12 molded cables wherever you've got this kind of connectivity. Simple, easy, quick, cost effective, and you always know as well if you've got a faulty cable. These are off the shelf. These are standard, industry standard. Okay, so it's not like we're going down the route of saying you've got to use a particular SIG cable or a particular SIG solution. We try and make this accessible to everybody, and we believe we're doing a pretty good job. Hopefully. Web server we've spoken about, very useful. The other thing, as I alluded to with regards to the sensors being able to be parameterized if you have a faulty unit, when you activate the data storage functionality, what you're effectively doing is taking that sensor's data and moving that setup configuration into the port itself. You can think of the port as having a small hard drive built into it. You can choose whether you use that or not. It's not a standard, so you could disable that. You could choose not to use that if you felt that that was better for your business case. However, the end user can benefit heavily from having that activated. So depending on where you are, what your business model is, you've got the option. Make life simple for the end user or make life better for yourself, depending on what your choices are. Very easy to use, very flexible, as you would expect. Format change of IO-Link devices, or you've got production. I presume most people have heard of the batch size of 1 by now at this point. Most companies don't tend to do that, but a lot of companies do have the ability to produce almost unique products on the fly. So Mini's a pretty good example. Any Mini that you order online, you literally put in all your different elements, and off the end of the production line comes a Mini to your specification, and they only made 1 of them. There was a batch size of 1. If you take that idea and move that across to the production line, all the sensors, all of the actuators, everything that's part of that production process effectively has to be configured to make that part. Because we can configure things remotely on the fly via IO-Link, it means that we don't have to stop the machine for any length of time. There's no physical interaction, there's no push buttons, there's no twiddlers, pots, damaged pots. We've all seen screwdrivers through the back of the pot and not be able to use it anymore. None of that, get rid of all that problem. A couple of specific use cases as well. We've got condition-based monitoring here. We sell a really cool vibration sensor, 3-axis vibration sensor, which can be connected over IO-Link. It is an IO-Link device, but then you can take that information and you can move it wherever you need it. Do you need it in the PLC? Is it meant to be used for direct change of events at the PLC? Or is it for storage on the server on premise? Or is it something you need to map to a cloud-based solution? All of that can be done directly from the IO-Link master, from our SIG 300. Another one of our key offers is compressed air monitoring. Again, we've got IO-Link versions of our FTMG, which is a very powerful and flexible flow meter. Communicate that information to the SIG 300. In this example, we're using it to generate data for the PLC, but the same things apply. We could go PLC, we could go server, we can go cloud. We can take that data wherever we need it to do analysis of use case of compressed air, save money, identify leaks, ultimately benefit your end user. And if the end user's happy, chances are they're going to come and see you for some more information or some more sales with a bit of luck. The final one, monitoring of glue level in dosing machines. So if anyone's ever seen an automatic glue system, there's always either a small tank or a larger tank silo where the glue beads have to be filled up, for example. If we're monitoring that level of the glue in the tank, not only can we give immediate feedback via a signal lamp tower powered directly from the device, but we can also take that information at the same time to the usual suspect again, PLC, servers or cloud-based solutions. Okay, so it's extremely flexible. It's launching on April the 24th, and I would encourage, if you've got time, come and see us on the stand and take a look at the devices in the flesh. See what you think. Give us some feedback, see if we've got it right, got it wrong, somewhere in the middle. All right. I would just like to thank you for your time. I appreciate you coming down and listening. Thank you very much.
Thank you.